Mobius strips, platonic solids, hexaflexagons, and the topic of this video, the pi versus tau debate. What do all of these things have in common? Most math classes skip right over them, and the worst part is, these are some of the coolest things in math, because they poke at your curiosity and make you think. Let's start with the basics. Pi is simply the ratio of the circumference of a circle and its diameter, and tau is simply the ratio of the circumference of a circle and its radius. And if you want to relate these two constants, tau is 2 times pi. Okay, you must be wondering now, why did I categorize this debate as cool in the beginning of this video? What's all the hype about? Well, in mathematics, everything is meant to be as beautiful and as elegant as possible. And in a mathematician's mind, beauty is defined by things like the simplification of a formula, the lack of coefficients, or the intuition that a formula has. But since certain people value some of these aspects more than others, a heated debate emerges where each side tries to prove why their constant is the best. A debate in math? That's pretty cool if I do say so myself. To explain this debate, I'll give a series of examples. Let's start with something simple. What if you were given a circle and asked to find its center? How would you approach that? You could draw 2 diameter lines that intersect, and then the center reveals itself. In this sense, the diameter is the fundamental length of a circle, and therefore pi should be the circle constant, since pi is the ratio of the circumference to the diameter. Let's keep track of this debate in our thought bubble. Pi wins this round. Pi looked pretty happy there, tau not so much. Let's see if things change after this next example, the unit circle. The circle of radius 1 that trigonometry is based on becomes genuinely more intuitive when tau is used instead of pi. One aspect of the unit circle is having a way to measure how far you go from the x-axis in quadrant 1. This angle measurement is called a radian. Specifically, 1 radian is the angle made when the arc that the angle projects onto the circle is exactly equal to 1 radius. Now that we know what a radian is, let's try to figure out, in radians, the size of the entire angle of a circle. To do this, we need to find the length of the arc that this angle projects onto the circle. Well, that would just be the entire circumference of the circle. First, let's try using pi. Circumference equals 2 times pi times radius. So, what's that in radians? Well, since radians are defined by how many radii can fit in the projected arc of the angle we are looking for, the entire angle of a circle is just 2 pi radians. Now let's try using tau instead. With tau, circumference equals tau times radius. And for the same reason that 2 times pi times radius corresponds to 2 pi radians, tau times radius corresponds to tau radians. Now, here's why tau is more intuitive when it comes to the unit circle. Because of what we just proved, one rotation around the unit circle can either be equal to 1 tau, which is pretty intuitive, or it can be equal to 2 pi, which, while still accurate, is less intuitive. Tau wins this round. Let's step back into our thought bubble. Another point of contention is the area formula. Piists, we'll call those people who like pi better than tau, love the area formula. It's simply pi r squared. It's beautiful and has no coefficients, unlike the atrocious half tau r squared. This round goes to pi. Let's go back in our thought bubble and see how pi reacts. Pi looked pretty happy. Tau not so much. Let's see what happens after this next example. Taoists, you guessed it, those are people who like tau better than pi, would say that despite the 1/2 and its unsimplified ugliness, it gives critical information to how the area formula was derived. It shows that the area of a circle was derived by cutting the circle into an infinite number of pizza slices, and then forming those slices into a rectangle. Pretty silly, but yeah, that's how it was derived, basically. Not really. The area of the rectangle is base times height. In this case, base is half of the circumference of the circle, which is half times tau times r, and the height is just the radius. So multiplying base times height gives you half times tau times radius, or half tau r squared. Let's check back to our thought bubble to see if tau is a little less angry. Yep, tau was definitely less angry. Pi looked pretty sad though, all those tears. Now I'll go into the biggest source of contention within the math community, Eulers Formula. Pi says, tau, will you really dare change e to the pi I plus 1 to e to the tau over 2I plus 1? That's hideous. Fractional coefficients are ugly. Tau responds passionately. Of course not. I would change it to e to the tau I equals 1. What now? To that, Pi says, you only have 4 important constants. My version has 5. You are missing 0. Tau responds, I can just add 0 to the end. And to that, Pi says, you can do that with anything. And to that, I would say enough. This video is dragging on too long. But I hope if you get anything from this video, it's 2 things. 1. This math debate, it's pretty cool, and it's pretty fun to talk about, but it's just a debate. There are no right or wrong answers, just different ways of looking at things. And Pi and Tau, they're just like people. They have their strengths and their weaknesses. And 2, finding beauty and intuition in the world, that's what math is. And this math debate is one of the infinitely cool things this beauty-searching subject entails. Tune in next time to find out how the Mobius strip was made.